Hello. Sometimes in engineering it is necessary to find a unit vector from one point in 3D space to another point in 3D space. So take a look here. This is 3D space on paper. Point 1, point 2. A regular vector would be like that. But sometimes we need a unit vector. Sometimes we need a unit vector along that red vector that I just draw. Let's call it vector R, and our goal is to find a unit vector along vector R. Okay. First, I'm going to give you the procedure on how to do it, and then I'm going to work out an actual numerical example. Okay, let's work out the procedure first. Let's say point 1 has coordinates in 3D space, coordinates A, B, and C, and point 2 has coordinates D, E, F. 2 points in 3D space. First, we need to find vector R, like I said, and vector R is simply going to be given by coordinates D minus A times unit vector I, we shall talk about later, plus coordinates E minus B times unit vector J, and finally plus coordinates F minus C times unit vector K. I, J, and K are unit vectors along x-axis, y-axis, and z-axis respectively. Okay, that's just a necessary explanation. Now, for simplicity's sake, let's say that D minus A equals G. These are simply numbers, okay? And E minus B equals H, and F minus C equals I. So that now R simply becomes G times I plus H times J plus I times K. The little arrows on top of the letters indicate that they are vectors. On a book, you would find them as bold, but I cannot do bold on paper, so we do it with a little arrow on top. Okay. So this is very important because now we have R, vector R, we have that, and we can now proceed to find a unit vector along R, which is what we often need in engineering mechanics. What a unit vector is, it means that its magnitude is 1. So the magnitude of U will be 1, just like the magnitude of I is 1, the magnitude of J is 1, and the magnitude of vector K is also 1. Let's turn to another page to continue. Now we need to find a unit vector along vector R. And the unit vector along vector r is simply given by the vector r itself divided by the magnitude of vector r, or more simply, vector r divided by r. The r without an arrow means the magnitude of vector r. The magnitude means the length, its length. Okay, and the magnitude of vector r is simply given by the Pythagorean theorem in 3 dimensions, and that would be the square root of g squared plus h squared plus I squared, the square root of all that. So the unit vector along the vector r will be g divided by r times I, unit vector I, plus h divided by r times unit vector j, plus I divided by h, no, sorry, r, these are all r's, times unit vector k. And this is the result that we need. Now I'm going to work out a numeric example so that you know what happens to all the numbers. Let's say that point 1 has coordinates 4, 3.3 and 7.2, and that point 2 has coordinates 8.1, -5 and 22. The vector r will then be 8.1 minus 4 times unit vector I plus -5 minus 3.3 times unit vector j plus 22 minus 7.2 times unit vector k. Which is 4.1 I minus 8.3 j plus, ¿cuánto es esto? 22 menos 7, 15, ¿verdad? 22 menos 7, 15, 15.2 k. ¿Verdad? Sí. Now we need to find r, the magnitude of vector r, which is the square root of 4.1 squared plus negative 8.3 squared plus 15.2 squared. I don't have that, so I'm gonna have to work it out. It comes out to 17.797. So now unit vector along vector R will be 4.1 divided by 17.797 I minus 8.3 divided by 17.797 J plus 15 times the point 2 divided by 17.797 K, which is equal to 0.235I minus 0.475 J plus 0.848 K, and that's what I need. That's the result, the final result. I'm happy with it. As you can see, it takes a long time. We need it constantly, many times in one single problem. So what I did was I wrote a little program in my graphing / programmable calculator, which I'm going to show you. That's it. Very simple. You might not know what it means. I will have to. It would take a few days to explain, so I can't explain it right now. But what I do is, okay. What I do is I simply input the coordinates of the 2 points on my calculator, like this: 4, 3.3, 7.2. That's the first point, the coordinates of point 1. Now the coordinates of point 2, which is 8.1, -5, and 22. The 2 points, the coordinates of the 2 points. I simply hit the key corresponding to my little program, and it gives me the 3 components of the unit vector along the vector R. 0.235, -0.475, and finally 0.848. I have rounded them to 3 decimal places for simplicity. But in a problem I would use I would not round it. Please rate, comment, subscribe, hit the like button. Good night, Tennessee. Bye.